Hello, today we're going to talk about spread footing design for columns. At this point, you have all of your beams and girders sized, and you did all of the loading calculations for those. So now the next thing we're looking at is transferring that load down through a column and to a foundation and ultimately to the ground. So here's a picture of a footing, a column. You'll notice that the load from above is being applied through this column down. Oftentimes there's a pier, which is just a chunk of concrete sitting on top of our footing. Notice that this is all directed in a vertical direction, so this spread footing happens directly underneath the column. So anytime there's a column, there will likely be a footing that's supporting all of that weight, that load from above. If we look at this diagram, notice here that we have a number of things happening on the column, a number of loads coming down the column. First one is our roof load, so anything that is any load from the roof is applied to the top of that column. We then have our second floor load that's applied to the column. We have this first floor and slab, but please note that that is not applied to our column because that, as it says here, if the ground floor is on a grade, on ground, then the load is not included. So if we have a slab of concrete that's poured over here, its load is being supported by the ground over here. It's not being supported by our footing over here. Please note that included in the roof and supported floor loads, we also have the weight of the column. The actual column is going to weigh something. And then the other thing is the weight of the foundation. So this chunk of concrete weighs something. We need to recognize that that is included in the overall load being applied to the soil. So to size this, so here's another diagram. You can see the loads coming down. Here's our foundation. We're going to have something called soil bearing pressure. And what that is that's the allowable pressure that that soil can withstand. What we need to do then is we need to figure out how big does this chunk of concrete need to be based on this pressure, based on the load, to support this whole load. Here's a very generic formula where it says the soil bearing pressure, Q, is equal to the load being applied, so that's the load coming down the column, and area is the area of the footing. Now, we would know this. We know the load coming down. We likely know the soil bearing pressure. I'm going to get to that in a second. What we're looking to solve for oftentimes is the area of the footing. How big does that chunk of concrete need to be? On this next slide, you can see, and you'll remember this from soils, we have all of these different allowable soil bearings based on the different soil type. So notice as we go from bedrock through to organics, our allowable soil bearing changes to where if I have bedrock underneath my building, I can withstand quite a bit more than as I go down this chart. So this would be known because we know what the site is that we're building on. So I can use one of these values. I know the load coming down my column. I can then size my foundation underneath there. So here's the example. So we have Q allowable. What this is this is the allowable soil bearing pressure. I'm going to go back one slide. So that's this column right here. I need to know that that is greater than or equal to my soil, bearing pressure. So Q allowable, the allowable soil bearing pressure, is greater than or equal to this load over area. Ultimately, this is the arrangement that we're trying to get to. The area, so the area of the footing, is greater than or equal to my load divided by my soil bearing pressure. However, there's also something else that we have to concern ourselves with, and that is the weight of the actual footing. Because this chunk of concrete definitely weighs something, we need to include that into our load calculation as it's coming down the column. So we have this P of the footing, load of the footing, is the thickness of the footing times 150 pounds per cubic foot. 150 pounds per cubic foot, that's the density of concrete. This thickness of footing is going to be how thick have I poured my chunk of concrete in the ground. Notice in this case, this is talking about 1 square foot of the concrete is going to be the area, but the thickness is what gets varied. Oftentimes it's somewhere between 1 foot to 2 feet. Generally not thicker than that, generally not thinner than that. So here's our Q net. Q net is our allowable soil bearing pressure. This is what was determined from our chart, minus the load of the footing will give us our overall allowable soil bearing pressure. So the area, again, I'm back to that equation, the area of my footing is equal to the load of the column divided by the allowable soil bearing pressure, and that's this right here.